Right. Now, the question number 1, right? Question number 1 is right. Let's sketch the graph of this y equals 3 minus 1x and y equals 6 minus 1. These two graphs we have to draw on the same diagram. And so otherwise, find all the values of x satisfying the inequalities. Okay. Yeah, I will first draw this one. Mod x graph. This mod x will first define. It changes at 0. This side it is x. This side it is minus x. Then on this side, on the right of 0, this equation will be 3 minus x. Left of 0, mod x is minus x. When you put minus x here, minus minus plus 3 plus x. Right? First, we have to put the x0 here to find x0 brings, right? y3, 1.03. Here also the same point. Okay. Now we can draw that diagram first. Right, this x-axis, y-axis, right. X 0, y3. 0, y3, suppose somewhere here. Another point we need to draw this. Right, that we take, put y0. When you put y0, what do you get? This, no? X is 3. Next point is 3, 0. 3, 0 here. The line is this. That line is this, huh? Is 0. And this part, this line now, here. 1 point, okay. Right, here put x is like minus 3. When you put x minus 3, 3 minus 3, y0. Right, to draw this two lines, people, 2 points we need, right? So then the 2 points, 1 point is 0, 3, that is a compulsory point. Put x equals 0 here and here. That is a definite, right? And the other one is any x value in the interval, right? I put that x is minus 3, where here, then y0, minus 3 is here. Another line is 90. This here. Then this equation, when you take y, 3 plus x, this one, y, 3 minus 6, first line is okay. Second line is okay. Right. That is mod x minus 1. You know, this mod x minus 1 graph is really by 15 mod x graph to write by 1 minute, you get that, no? Yeah. So if I define this, I'll take that. This changes at 1. This interval y equals 6 minus 1. This interval minus of 6. minus x plus 1. No? They also put x equals 1. This value 1, we have to definitely put for this x to find one point. X equals 1 brings, put 1 here, 1 minus 1, y 0. 1 point is 1 0. X1, y 0. Where's that here? Some people see, no? Some people see. Right. Here also, so this one is 1 0, we have to come. Another point we need here. So that I can take its intercept. Intercept is minus 1. Here. Minus 1. No? You have joined this and this. And the line you have produced this way. Right. You can see people here. Here the gradient is 1. This line also gradient 1. The line we are going to draw is gradient 1. This also gradient 1. Therefore, this line and the line here we supposed to draw should be parallel each other. Like this, when we draw a line here parallel to this one, remember that. This way we get that one. Right. Now, this interval, this point is 1 0. Its intercept is 1 plus 1 here, somewhere here plus 1. Then this line is passing this way. Now, the gradient of this is here minus 1. The gradient here, this one also minus 1. So, therefore, the line we are supposed to draw here, this way should be parallel to this. Approximately, we have to maintain that geometry, right? This one. Right, okay. This is how that we get. Then this equation y plus x minus 1. This equation y plus minus x plus 1. This way we get the 2 graph. Right? Can you see the board clearly, people? Right. Okay. Now we'll find this point. Suppose this point is A. This point is B. I will find these points A and B. Point A you can find how? Point A. This point no? Solve this line and this line, the equation. That means equate the right hand side. B plus x equals minus x plus 1. 2x minus 2. No? Take this minus right hand side. X is minus 1. Here. Point B. How? Equate this and this. X minus 1 equals 3 minus x. 2x equals 2. X is 1. X is 1. No? Here. X is 1. Right. What is asking the question? Question asking is this mod x plus mod x minus 1 less than or equal to 3. Take this right hand side. Mod x minus 1 less than or equal to 3 minus mod x. Okay. Right. 3 minus mod x graph is this. That should be here greater than the other. That means the black graph should be above the blue graph. That happens between the 2 points A and B. And equal sign also there we have. Therefore, this occurs in between -1 and +1, no? X less than or equal to -1 +1. Why we have to put the equal sign? Because we are asking equal sign. Equal sign means the two graphs have the same y value. That point also you have to consider. At 1, the height y values of the blue one and black one being equal, -1 also blue and black one being equal. Therefore, the equal sign you have to include, right? Yeah, that's how we take it one. Huh? Second question take. Question number 2. Okay, now people, I'll erase this now. Right now. Yeah, second one is a limit one. Limit question. Limit x going to 0. 1 minus cos 5x by 4 divided by x squared times x plus 1. You know, now here I can write this cos 5x by 4 using the half angles. Huh? Limit when 0, 1 minus, open a bracket. If you assume this as cos theta, for cos theta we have half angle formula. What is that? 1 minus 2 sine squared this angle divided by 2. When you divide this angle by 2, it will be 5x by 8. Like this, huh? X squared x plus 1. In the 1 minus 1 we can cancel down. No? Minus 1 is plus. Right. Limit from 0 to sine squared 5x by 8. Right. Now I keep this x squared here. This x plus 1 I keep like this. 1 of x plus 1. Okay. Now this is what I do. I write here 5 squared. Here we have x squared, here 5 squared. To cancel down this 5 squared, I write here 5 squared. And right, I am writing here 64. To cancel down this 64, I write 64 here. And 64 is below this line. Now, this 2 and 64 we can cancel down. 5 squared by 32, that is a constant, take it out. Limit x 0. Now here 5 squared x squared, and here 64 I can write as 8 squared. Here we have sine squared. Then this whole thing I can write sine 5x by 8 divided by 5x by 8. Whole thing squared. Correct. No? Whole thing squared. We want to square this. We get this two both. Limit x 0 we applied here. We now apply that here too. Like this. Huh? Now you get the answer. No? 5 squared by 32. What is this? When you bring this limit x going to 0 inside this, you can see this 5x by 8 you can consider as theta. Then here we have sine theta by theta. X going to 0 means any multiple of x going to 0, 5x over 8 also going to 0. Then here we have what? Sine theta by theta. As x going to 0 means theta going to 0, sine theta by theta. Theta going to 0 means this is 1 squared coming. 1 squared. Here when you put 0, 1 upon 1. is nothing but y squared by 32. This is how we take it. Right, number 3 take. Yeah, a curve C is given by parametric equations x equals L in tan t by 2 and y equals sin t for t is in between 90 and 180. So that dy by dx is cos t sin t. We'll see. X number 3. L in tan t by 2. Y given sin t. Okay. I will differentiate this. Right hand side we have t, no? Then we can differentiate the right hand side with respect to t dx upon dt. Right. First, ln log, when you differentiate log, what do we get? 1 over the function inside this log. 1 over tan t by 2. Thereafter, it should be multiplied by the derivative of this tan t by 2 with respect to t. Derivative of tan x with respect to x is x squared x. Then tan t by 2 with respect to t is x squared t by 2. X squared t by 2. Not only that, finally, we have to multiply that by derivative of t by 2. Correct, no? First, ln, here we got, then tan t, its derivative is here. Now, derivative of t by 2. Derivative of t by 2 means really half t. Then keep this half as the same, and derivative of t with respect to t is 1. So, therefore, it is half. That's what we get. Secondly, right here, dy by dt. It is cos t. Now, asking to find dy by dx, no? Right? Dy by dx. You have to find dy by dx. Right now, you have to apply chain rule. Right. The earlier question asking here, do we need to put this x1 0 as 5x by 8? No. That is not that much important because we know as x1 0, any multiple of x going 0. Therefore, that is not that much important. Right. Let's put like that. Right now, divide by t equals 3. Now, by chain rule, you can write. By chain rule. What is chain rule, people? Dy by dx is equal to dy by dt into dt by dx. Dy by dt is that constant. Right. dt over dx means the reciprocal of this, no? dt over dx. Take this goes to numerator. 2 also going to numerator. 2 tan t by 2. 6 square t by 2 come into denominator like this. Okay. Okay. Now simplify this. What do you get there? Okay. Simplify this and take the answer. Okay. Now 2 cos t tan t by 2 I can write as sin t by 2 divided by cos t by 2. Here 6 square t by 2. 6 square t by 2 means 1 upon cos square, no? Cos square t by 2. This we can put here like this. Cos square t by 2. Yes, we can cancel like this, no? Then 1 cos t by 2 you can cancel on this. Now what do you get? dy by dx. We get how? This cos t I can write this 2 sin t by 2 cos t by 2. We can write together like this. 2 sin t by 2 cos t by 2. This is really what? 2 sin t by 2 into cos t by 2 means sin t. Yeah? Sin. Then we get dy by dx as here cos t, 2 sin t by 2 cos t by 2 is sin t. Then sin t cos t comes. Sin t into cos t. But deduce that the gradient of the tangent line drawn to the curve C at the point corresponding to t equals 2 pi by 3 is this much. Yeah. Gradient. Gradient means dy by dx value, no? Dy by dx value where? At the angle t equals 2 pi by 3. T equals 2 pi by 3. Then substitute to the right hand side this sine and cos 2 pi by 3. Sine 2 pi by 3 is what? Sine 120, no? Sine 120 is root 3 by 2, no? Cos 120 is minus half, no? Incorrect, no? Minus root 3 by 4. Right, no? Come to question number 4. Question number 4. L1b, the straight line x plus y minus 5 equals 0. 4. L1. Suppose this is line L1. With the equation x plus y minus 5 equals 0. Find the equation of the straight line L2 passing through the point P3, 4 perpendicular to L1. Perpendicular to L1. This is L1, the line perpendicular to L1. That line is given as L2. Okay. This line is passing through where? P 3, 4. Okay. P 3, 4. Right. Now, how to find that? You can write it like this. When I find the gradient of this, take x and minus 5 right hand side. What do you get? Y equals minus 6 plus 5. This is the gradient. Minus 1. The gradient of this is minus 1. Understood? Then the perpendicular line, I will find its gradient. The reciprocal of this you have taken multiplied by minus sign. Reciprocal means 1 upon minus 1, again minus 1, multiplied by minus sign, you get plus 1. This is therefore the gradient plus 1. Suppose in that. Then gradient is known, this point we know. Then using this y minus y naught equals gradient times x minus x naught. You can find the equation of this. Y minus y naught, this one 4. Gradient is now 1. X minus x naught is 3. Okay. Then we can take the answer here. It is this side. Y minus x minus 1 equals 0. This is the equation of L2. y minus x minus 1 equals 0. Now given next one, let Q be the point of intersection of L1 and L2. This is that Q. Right. Let R be the point on L2 such that PQ QR 1 is 2. PQ QR 1 is 2. Somewhere here we have R. PQ is to QR 1 is to 2. This is 1, this is 2. Find the coordinates of R. I'll take coordinates of R as alpha beta. Before that, I am going to find this point Q. Point Q can easily be found by solving these two equations, L1 and L2. Solve this L1 and L2. X plus y minus 5 equals 0. Other one, y minus 6 minus 1 equals 0. When you add them up, what happens? 6 minus 6 will cancel off. Here, 2y come in. Here minus 6. Take it right hand side plus 6. Y is 3. Okay. Put that y3 where here. 3 minus 5 is minus 2. Take it right hand side x2. Therefore, Q is what? 2, 3. This point. Now we can apply the ratio theorem. What ratio theorem? This exponent 2, you can write using this alpha 3, 1 and 2 by ratio theorem. By ratio theorem. But you get this 2 you can write. How? 2 equals 1 into alpha. 2 into 3, 6. Divided by 1 plus 2 is 3. Alpha 0 coming. Y coordinate 3. This one, I can write how? 1 into beta. 2 into 4. 1 into beta, 2 into 4, 8, divided by 3. This is cross multiplication, 9, bring this to this side, beta is 1. Then, point R, we get as how? 0, 1. Right, 0, 1. Right, next question. Question number 5. So that sec cube x plus 2 sec squared x tan x sec x tan squared x is equal to this. Right, this is finished. We take to, we'll come to the number 5. Now I guess this, okay. Number 5. Sec cube x plus 2 sec squared x tan x plus sec x tan squared x. Sec cube x means 1 over cos cube x. Right. Here tan x means sin x by cos x. Sec squared x means 1 over cos squared x. Then denominator here, cos squared x here we have another cos x here we have, it is coming by tan x, because tan x is sin x by cos x. That cos x and sec squared x means 1 over cos squared x. This cos squared x and this cos x, cos cube x. Numerator, tan means sin, sin and this 2 sin x divided by cos cube x. 2 sin x divided by cos cube x. Here, Tan squared means sin squared by cos squared. If sec x means 1 over cos x. Cos squared x, cos x, cos cube x. Numerator now we have sin squared x. Sin squared x divided by cos cube x. Yeah? Now the common numerator is cos cube x. Numerator what we have? 1 plus 2 sin x plus sin squared x. Huh? This is. But you know, this numerator you can write, it is the perfect square of 1 plus sin x. When I take the perfect square of 1 plus sin x, what is it? What is it? Square is 1 square, 1. Middle term, this is 2, this is coming. Next one, sin x square, this is coming. Huh? Divide by what? Cos cube x, I can write like this. Cos x into cos squared x. Okay. This cos squared x, you can write how? 1 minus sin squared x. Okay. Cos squared x, you can write like this, no? Cos squared x is 1 minus sin squared x. This 1 is 1 square. Now here we have difference of 2 squares. What are the factors? 1 minus x into 1 plus x. And then directly put that here. 1 plus sin x perfect square divided by cos x. This cos squared x we write as 1 minus sin x into 1 plus sin x like this. Huh? Then what happens? 1 plus sin x term we can cancel on with this. Now what I do? The numerator, denominator, both I multiply by 1 minus sin x again. See what happens. One plus sin x. We multiply both the numerator and denominator by 1 minus sin x. No. Divided by here cos x. 1 minus sin x. Again we multiply by another 1 minus sin x. Then 1 minus sin x perfect square coming. Correct, no? Then you can very clearly see again here. What is this? 1 plus sin x, 1 minus sin x means 1 squared minus sin squared x. 1 squared is 1, no? Divided by cos x times 1 minus sin x perfect square. No? But what is this 1 minus sin squared x? 1 minus sin squared x is cos squared x. Then here 1 cos x, we can cancel down with this cos squared x. This is. Then numerator we have cos x, denominator we have 1 minus sin x perfect square. No? Cos x divided by 1 minus sin x perfect square. No? This way we get the answer. Okay, right. We can go to the applied part. Question number, yeah, next part 1. Applied part. Right. Go to applied part. It says two particles A and B of masses 2m and m respectively moving on a smooth horizontal table along the same straight line towards each other with the same speed u collide directly. Just after collision, the particle A comes to rest. Here the coefficient of restriction is half. Okay, now this is A and B. A, B, A has mass 2m, B is in, are moving on a smooth horizontal table along the same straight line towards each other with speed, same speed u. Each other with speed, huh? Right. Just after collision, the particle A comes rest. After collision, A is at rest. 2m no velocity. When A is at rest, definitely we should go to other direction, no? With suppose W. Why? If this B trying to move this direction, then automatically this A will get another velocity to move leftward. Understand? Right. Though you put suppose this W leftward, never mind, we get the answer. Hmm? Yeah. But we know practically if this comes to rest, then B should be reversed. Now what is asking there? So that the coefficient of restriction is half, and that the magnitude of the impulse exerted on B due to collision is 2 mu. Now we'll apply Newton's law of restitution rightward. Newton's law of restitution says what, people? Minus c times relative velocity before impact. After impact, A is at rest, no? Then before impact also, we'll keep this A at rest. How to keep A at rest? Apply this present velocity of A is rightward, no? To the left. Then we have to apply U left. The same U we have to apply on this B left. Then this B will get U 2U to the leftward. But we apply NLR rightward, no? It should be minus 2U. That is the one side of the Newton law of restitution equation. Minus E times relative velocity before U, before impact. After the impact, we know A is at rest, no? Then this W is the relative velocity, right? In case right for the already W. In one equation we get 2EU, number one. The second equation we apply conservation of linear momentum. That also we apply rightward. Before impact, the total momentum is equal to total momentum after impact. Right. So this one, 2mu. This u is leftward, therefore minus mu is equal to mw. We can cancel down. Here we get u because w. Put here w value 2eu. U and u we can cancel down. Here we get 1. Then bring this 2 here, e equals half. We get e as half. E as half. Now let us ask you next. Show that the magnitude of the impulse exerted on B. Exerted on B. Right. Now at the impact, this is what will happen. I am drawing now just before the impact. Just before. Just before they move this way, you know. M here, AB. At that moment, equal and opposite impulsive forces act. At the impact, equal and opposite impulsive forces, suppose D. Right, this is A, this is B. Thereafter, what happens? Now this A is at rest, no? A is at rest after impact, given in the question. Right, this is 0. But B is moving this way with velocity W. This is 2m, this is m. AB. Now I'm going to calculate the impulsive force acting on A. It is J. The same J acts on the B. Then what I do is this. If I consider this way here, if I consider A, this one, mass 2m, Just before impact, it can be velocity u rightward. At the impact, impulsive force coming leftward j. Soon after the impact, it is rest move velocity 0. Now we apply I cos delta in V for this particle A, say rightward. What is this delta in V? Delta stands for change. MV is the momentum, change in momentum. How to find change in momentum? Final momentum minus initial momentum. Here final means what? After impact. Huh? After impact. Understood? Right? So then after impact, rightward direction, momentum is, right? Here you can see after impact, no velocity, no, 0. Minus before impact, rightward direction, the momentum is 2mu. 2mu. I, the impulsive force acting, it is acting leftward here, minus J. Why we should put here minus? Because we apply this equation rightward. J is leftward. That is why we have to put minus. This time this we can cancel it out. Then we get J equals 2mu. The same J only acting on what? B. Right? Okay. So therefore the impulse is 2mu. That's how we take this answer. Right now? Right. Right now, number 2 says the particle is projected from a point on the horizontal ground at an angle alpha. This way. With velocity to 2gr. This, yeah. Where r is the horizontal range. Here, horizontal range is r. The same r here we have. So that the angle between the two possible initial directions of projection is pi by 3. Now, I take this point as O and this as A. For OA motion, we apply S equals ut plus half AT squared upward direction. Right. So then once it comes from O to A, upward direction, no displacement. S is 0. U 2gr root sine alpha. Root 2gr sine alpha times t plus half a is minus g t squared. 1 t you can cancel out. Then bring this to this side, subject t. What do you get there? Also bring this to this side, this term will be positive. By this 2, you can multiply this. By this t, you have divided. Then 2 times this we get 2gr sine alpha divided by g. I think you can understand that. Bring this to this side. 2 is denominator, use the cross multiplication. G is here, bring it to here. This is the time of flight. Okay. Now we apply S equals ut rightward. For the motion OA. This length is r given. Velocity is cos of this root 2gr. 2gr root cos alpha. Time is this t. Put that here. 2gr sine alpha divided by d. Right. This is how we think, people, in this case. Here, root g, no. Here also root g. Root g, when you multiply, we get g. Then by this root g and this root g product, we get g. That numerator g, we can cancel down with this g. Then this 3 we can cancel down like this. Next one. Here 2 are root. Here 2 are root. Then get together 2 r. R equals 2 r. Correct, no? Another 2 sin alpha cos alpha. This r and this r we can cancel down. This 2 sin alpha cos alpha is sin 2 alpha. Take this 2 here. We now here 1, no? Then sin 2 alpha is equal to half. Sin 2 alpha is equal to half. What is sin 2 alpha half mean? Tell me people, 2 angles for sine rings half. First one is what? 2 alpha 5 by 6. Right now, if this place we have 30, 30 means 5 by 6, no? Sine 30 half. Then what is alpha? 5 by 12, taking here. Another angle, tell me for 2 alpha for the sine to be half. Sine 150. Sine 150. Sine 150 is again half, no? Right. This angle is 150. Then this is 75 degrees. People, what is 5 by 12 really? 5 by 12 means 1 is divided by 12. It is 15 degrees. 180 when you divide by 12. 15, no? Then you can see here, for this sin 2 alpha to be half, we can find 2 angles for alpha. One is 15, other one is 75. What is alpha? Angle of projection. Then there are 2 angles of projection to achieve this. One is 75, other one is 15. So we can see the difference. 75 minus 15 is really what, people? 60. Therefore, angle between the 2 possible directions is what? One is 75. One is 75. Other one is 15. Then the angle between them is 75 minus 15, 50. Therefore, angle between the directions of projection is 75 minus 15. This is nothing but 60. It is nothing but 5 by 6. Okay. That's how we take that. Right. Next one. Okay. Now we are given a particle P of mass M. Right. We'll draw this diagram. As in here, particle P. Here, lambda M. Q. System is raised from rest with the spin taut, as shown in the figure. The particle P moves downward with acceleration g by 2. This moves with acceleration g by 2. We are given this moves with acceleration g by 2. What are the forces here? mg. This is lambda mg. Same tension in the string. Because why? Right hand inextensible. Right. You know, when this P moves downward with acceleration g by 2, the other end of the string should move upward with the same acceleration g by 2. That's the obvious fact, no? Yeah. This moves this upward direction with acceleration g by 2. Ask me to show lambda 1/3. Now apply F equals ma for P downward, then Q upward. Thereby You can take this answer. Huh? F equals MA, we apply number 1 for P download. What do you get? Mg minus T equals Mg by 2, number 1. Secondly, for Q upward, what is that? P minus lambda Mg equals lambda M times G by 2, number 2. At this 1 and 2. Minus P plus P can cancel down. Left hand side, Kmg, this is minus lambda Mg. Right hand side, Mg by 2, here, lambda Mg by 2. Mg you can cancel down here 1, this way, you can cancel down Mg. Mg we get 1 minus lambda, here half, here lambda by 2. Okay. Now bring this side, 1 minus half come in, no? It is half. Take this right hand side, this is plus lambda, no? Lambda plus lambda by 2 means 3 lambda by 2. Cancel down these 2. Bring this 3 we are here, 1/3 come in for lambda. This gives lambda equals 1/3. Lambda is 1/3. Huh? Okay. If the particle P strikes a horizontal inelastic flow, people, what is meant by inelastic? Remember this way. When we drop a particle onto an elastic surface only, that bounces off. Okay. When you drop to inelastic surfaces, the objects never rebound. Okay, then what happens? This particle P coming right down, and one location flow with speed V. All right. We strike a horizontal inelastic flow with speed V, and the Q never reaches the pulley. Find the time taken by the particle Q to reach the maximum height from the instant when the particle P stands the flow. Particle P starts the flow. Right. Now this is how we think, people. Now suppose somewhere here we have the inelastic what flow. Now P is coming like this. We are given the velocity is V. Now the other end, particle Q, suppose it is somewhere here. At the moment this P strikes the inelastic ground. You can very clearly see here, when the particle P has a velocity V, the other end of the same string will have the same velocity V upward. Then at the moment P strikes the inelastic plane, this Q will have velocity V upward direction. Thereon what happens? This particle P does not go up. It sticks with this, suppose. Then what happens? Particle P can't move because it can't move down to the plane. But particle Q has velocity V. Then with the particle Q with the velocity V begins to move up. Then suddenly what happens? The string goes flat and no tension. Then no longer the earlier G by 2 acceleration coming toward this particle, because to give this G by 2 acceleration, C is the main force helping, right? But this can't go move, this can't go down, this can go up. Due to that, what happens? The string goes flat. Therefore, tension will be 0. then no longer this g by 2 acceleration comes towards this particle q. Then what happens? Now the situation is when we project a particle upward direction with initial velocity v, the same thing this particle q now experiences. What happens when we project a particle upward direction with velocity v? Particle move under gravity with retardation. Then with retardation v, that moves to maximum height and comes to rest and coming back. Now asking what? The height, the time taken to reach the maximum height. Therefore, at the maximum height, you know, the velocity of the particle q is 0. Apply for the particle now, v equals u plus at upward direction for its motion under gravity. Now, v equals u plus at, we apply upward for q. What happens? v0, find velocity. Initial velocity is v, acceleration is minus at, then t equals v over g. After this time, from the particle t struck the ground, it comes to our maximum height. That's how we take it out. Okay, right. Our next one, question number 4, vector question. Yes. In the usual notation, let 3i and 2i plus 3j be the position vectors of 2 points A and B respectively, with respect to a fixed origin O. Let C be the point on the straight line OB such that OCA pi by 2. Find OC in terms of I and J. Right. Okay, this way we can think. Really, it's not necessarily draw this on the OXI Cartesian coordinate plane correctly. We can take the answer, right? But I go like this. 3i. 3i means what? A vector. What is the point? X-axis 3, 0. This is 3i point. 2i plus 3j. What is the point with this position vector? X coordinate 2, y coordinate 3. 2, 3 point has this position vector. 2, 3. Suppose somewhere this way we have 2, 3 point. 2, 3. Then this is that position vector. 2y plus 3j is this. 3i is this. Right. What is the next given? The points are, this point is A, vector 3i, this is B. Right. C be the point on the line OB. Here. OCA 90. OCA we have C. OCA 90. This, yeah. This is 90. Find OC in terms of I and J. OC. Right. Now we can think like this. OC vector, no? You can see the OC vector, and when we consider OB vector, they lie in the same line. Then we can write this OC vector as a part of OB vector, no? Right? OC line and OB line being on the same line. So therefore, OC vector we can write as a part of what? OB vector. Then I can write like this. We can write let OC vector equals K times OB vector. What is K? K is a real number. In OC vector, I can write. We need to find this K. Yeah? K, OB vector. OB vector means 2i plus 3j. Right now, OC vector. This way you can write. Now, OC means this function vector of C. Yeah? Right. Now I am going to write CA vector. CA vector. This is how to write CA vector. Position vector of second letter minus position vector of first letter. Understood? Position vector of second letter means position vector of A. It is given as 3i. That minus position vector of C. We assume this way. OC means position vector of C, because always the position vector means that vector should start from the origin, ending at that point. That vector only we define as the position vector of the point. Then it is OC. OC is this. Now we assume K times 2i plus 3j. Okay. Now I am going to collect this items. Here when you remove bracket, what we get? 2i. Here we have 3i. Take I out. What do you get? Here 3, K minus 2k. And here remove the bracket, minus 3kj. Correct, no? Okay, then CA we found. Now, people, we are given the OC and CA are perpendicular. You know, we learn dot product in the vectors. You know, when two vectors are perpendicular, suppose here we have two vectors A and B, they are perpendicular. We know when two vectors are perpendicular, then the dot product of these vectors is equal to 0. A dot B is 0. Like that here, this OC and the CA also perpendicular vectors. Therefore, OC dot CA should be equal to 0. OC vector is this. K times y plus 3j. CA vector is 3 minus 2k I minus 3kj equals 0. You know, people, when we need to take a dot product of two vectors which have been expressed in IJ form, we know how to take that. I take this K out, open the bracket. Now what we do? We have to take dot product, this vector and this vector. How to take that? Multiply I coefficients. This I coefficient 2, here 3 minus 2k. 2 times 3 minus 2k. Okay. And multiply j coefficient. This and this minus 3 and 3, 9k equals 0. Now we have k. Remove bracket here, 6. This and this minus 4k. And here 9k minus 13k equals 0. This way we get. This product is equal to 0 means either k 0 or this 0. Right? This gives us what? K 0 or k 6 minus 13k equals 0. But people, k can't be 0. Why? If k is 0 here, k 0 means 0 into OB means this is null vector, 0 vector. Then OC is equal to 0 vector. That means C should be the origin. It is impossible now. Therefore, this k equals 0, impossible. This is impossible. Then the k value should come from this. Then substitute k value by that. What do you get? K equals 6 by 13. Right. Now we need. Now put that k here. Then we get OC, question vector of C. Let's ask you now. OC ask you now. Right. Therefore, OC. Therefore, OC you can write. Therefore, OC you can write how k is what? 6 by 13. What? 2i plus 3j. This is how we take our C vector. Right. We'll come to question number 5. Question number 5. Right. The last question in applied. Okay, right. Yes, there you are given a uniform rod AB of length 2a. Uniform rod means center of gravity is at the midpoint. And where W is held in equilibrium by a light injection slow stream BC and by a horizontal force P applied at the end A, as shown in the figure. Given that the rod makes an angle of 45 degrees with the horizontal, so that the angle theta that the stream BC makes with the horizontal is given by tan theta equals 2. Right. First, we'll go diagram. Is the rod. The force here P. Rod makes an angle 45 with the horizontal. Here B. This is string. Tension T, right? This is the ceiling. Point C. This angle given to be theta, no? Center of gravity is at the midpoint. Where W acts like this, It's C. Okay, now the length of the rod is 2a. It's a uniform rod. Yeah, this is A, this is A. Right. Ask in what? Given by tan theta equals 2. Find the tension of the string in this question in terms of W, right? Okay. Now we do like this, people. For the equilibrium of the rod, the resolve force of horizontally vertical end will take moment. Right. Okay. Now you can write now for the equilibrium of the rod. For the equilibrium of the rod, resolving horizontally. What do you get? E cos theta equals P. Number 1. Resolving vertically, P sin theta equals W. No? P sin theta equals W. Number 2. And we'll take the moment. We take a moment for the equilibrium of the rod. Right. I'm going to take a moment around B. O A also possible. I'll take around B for the equilibrium of the rod. Right. Take a moment around B. Right. I'll take a moment around B clockwise. So you know when you take a moment around B, this P force, right? By the force P, when we push this way, the rod begins to rotate this way clockwise. Therefore, moment of this force P around V this way clockwise. What is the moment? P into perpendicular distance. This is a perpendicular distance. Here 2a, this is 45. Opposite side is this is 2a sin 45. No, opposite side we find like that. No, P into 2a sin 45. This way, right? P into 2a sin 45 is equal to, what is W around B, right? When you pull down like this, the rod has to rotate this way, anti-clockwise. What is the moment? This is line of action of AW. So that line, the perpendicular distance we need is this. The length from here to here. Okay. You know, this is 45. This is also 45. Why? This W is vertical now. Therefore, this is 45. Then the required perpendicular distance is this. The length from here to here, A. This is A, this is 45. Therefore, this is A sine 45 again. So what do you get? W into A sine 45 is the moment. In A sine 45, you can cancel down like this. P is W by 2. Okay. Now what we do? Divide this 2 by 1. We divide 2 by 1. We divide 2 by 1. What happens? P sine theta divided by P cos theta. Here W, here P. This and this you can cancel down. Sin theta by cos theta is tan theta equals W divided by P. P is W by 2. This W you can cancel down. This 2 goes to here. Gives us what? Tan theta is 2. What is asking next? Tension in the spring. T we need to find. Tan theta 2 means you can draw a triangle for this. Tan theta. Right, tan theta 2 means what, people? Tan theta 2 means 2 divided by 1, no? Tan means what? Opposite side divided by the adjacent side, no? Opposite is 2, adjacent is 1. Here this is 2, this is 1. Then you can find this hypotenuse by using the Pythagoras theorem. What is that? 1 squared plus 2 squared root. 1 squared is 1, 2 squared is 4. 1 plus 4, 5. Its root is root 5. Therefore, this is root 5. Then we can write cos theta. Adjacent side divided by the hypotenuse. This way. Right. Now you can use number 1. Now by 1. What is that? P. Cos theta. 1 over root 5 equals P. P we found W by 2. Bring this side. P equals root 5 by 2. This is the tension in the